Hi viewers, welcome again. This afternoon we are going to look at advanced level of calculus. Actually, I've not started calculus, but someone sent me this question and I'm sending it to a class and I know it's very important. We are still going to do this when we start a calculus. And I want to start from elementary differential equations. This is for institutions. In this topic, we shall be examining number one, definition of elementary differential or differential equation, and again we shall be examining order of differential equations. Again, we shall be considering what we call general and particular solution of differential equation. And again, we shall be examining the methods or the formation of a differential equation or formation of differential equation, particular solution. This is solution and differential equation. And again, we shall look at methods of solving differential equation. So these are what you want to consider in this topic. But for this course, we are going to split it into different parts. So if you are new here, try to subscribe and click on the notification bell so that you will be notified anytime I drop or upload any of these videos. For today, I will look at definition, I will look at order, particular and general solution, and also I will look at formation of a differential equation. But in my next video, I will continue with methods of solving differential equation. So let's go. What is differential equation? That is what you want to consider first. Differential equation. A differential equation is a relationship between an dependent variable x, a dependent variable y, and one or more one or more derivative of y with respect to x. So this is the definition of a differential equation. A differential equation is a relationship between an independent variable x, a dependent variable y, and one or more derivatives of y with respect to x. For us to understand this definition better, we need to consider what you call variable, that is dependent variable. We have a independent variable and dependent variable, and also derivative. These are the three things mentioned in this definition. So when we say dependent variable, dependent or independent variable, independent variable x, and we also say dependent variable, dependent variable, which is y, and we also mention derivative. These are the three things, or these are the three elements in this definition. When we say relationship, we know that is a kind of equation that connects this. Just like variation is what referred to as relationship. They are related with each other or related with one another based on their parameters. So we make mention of this independent variable. Just consider this, for example. Let's say you have this equation equal to beta naught plus beta 1x. In this equation, we can see that y relates to this. That is, they have a relationship. They are connected. But in this type of equation, y depends on x. Yx is independent. When we say y depends on x, we are trying to say that without x, we cannot have y. And without y, we can have x. Therefore, y depends on x. It's just as when we say income and expenditure. Income, expenditure. Without income, nothing like expenditure. So expenditure depends on income. That is what we are trying to say, that if y is our income, if y is our expenditure, then income will be our x, which means that y depends on x. If this variable increases, it will affect the value of y, and if this variable decreases, it will also affect the value of y. It means y depends on x in this relation. That is what we mean by dependent variable and independent variable. And when we say derivative, it has to do with the rate of changes. That is, the rate at which y changes with respect to x. That is, what will happen to y if x changes, either increases or decreases. The value of y will change. The rate of changing with respect to this is what referred to as derivative. And in mathematics, we denote it as dy with respect to x. That is, dy ds has to do with change in the value of y with respect to the change in value of x. That is, when the value of x changes, how will the value of y also change? That is what referred to as derivative. So this is the y, the x. That is the derivative of y with respect to x. Then x is independent. That is, x does not depend on y. Y depends on x. Then the relationship between this and this with one or more of this derivative of y with respect to x is what referred to as differential equation. That is the definition of differential equation, and that is the best way I think we can explain differential equation. So these three things explain better what differential equation is. Now we want to look at the second one, order of differential equation. Order of differential equation. Order of differential equation. When we say order of differential equation, it has to do with the order of the derivative. That is, what or how many times does this value of y changes with respect to x. So if it is once, then we say the order is 1. And if it changes twice, the order will be 2. And when we say order, order has to do with the order form of the derivative that the value of y changes with respect to x. E.g., let's say you have a number 1. If you have x dy with respect to the x plus 2xy equal to 0. So this type is order or first order. We call this first order. We call this first order because it is differentiated, or the degree of the derivative is 1. If you have the scale y, the x square minus y plus 2 equal to 0, this is second order. This will be second order. Second order. That is order of 2. The degree of the derivative here is 2. And when you have this, like the square y, the x square plus x into the y, the x, all raised to the power of cube plus 2 equal to xy. What will be the order? Here we are not considering the power. This is just the power, but not the degree of the derivative. We are still in order of 2. So this is the highest degree of this derivative. This is also second order as above. So if you continue like that, like let's say you have another one like the cube y with respect to the x cube plus the square y, the x square minus x, the y, the x plus y equal to 0. This will be degree of 3, that is order or third order. Third order. So this will be third order. If you continue like that, we can have an nth order. These are what we refer to as order of differential equation. That means we are done with this. Now we are going to general and particular solution. General and particular solution. What do we mean by general and particular solution? General and particular solution. this general solution, consider an integration y equal to integral x squared plus 3x with respect to the x. So this is an integration. If we are to integrate this equation, this will be y equal to x cubed, that is, we are adding 1 to this, which is 2 plus 1 over 3. We are dividing by the power as well, plus 3 x to power, this is 1 plus 1 all over the power, which is 2. Then we are adding a constant term, which is called derivative terms. So this will be y equal to x raised to power of 3 all over 3, then plus 3 over 2 x squared, then plus c. This is what we refer to as general solution of this problem here. The general solution is this, in the sense that we are concerned with the derivative constant. So anytime we integrate, we put this constant term, which is integration constant. It is constant, and we are putting this constant to avoid ambiguous answers. A situation whereby someone integrates and that person refuses to put this, the person will also get this. For example, if we differentiate this, we are going to get this as well, x squared. And if we differentiate this, we are also going to get 3x. But if we put constant as well, and if we differentiate constant term, we know that the derivative of constant term is 0. So it will not also appear. But a situation whereby someone can write 3 here, 4, 5, to avoid ambiguous answers. That is why we are putting this integration constant. So we assume it is general and it is universal. When we integrate, we put constant. And this solution is what we call general solution. But if you want to know a particular solution that this equation belongs to, we need to find the value of c. Our c may be 5, c may be 10, may be 7, may be anything. Then when we solve further to solve this equation, then we now find what we call particular solution. An example of such is this. Let's take this question, for example. Find the general and particular solution of the differential equation at the point A, or at the point 2, 3 and 2, 5, or let me say 0, 2, 0, or let's make this 0, this is 0, and this is 1. So let's find the general and the particular solution for this differential equation. Find the general and particular solution of the differential equation at the point this. So this is the differential equation. The y, the square y, the x squared plus this is equal to 4x plus 3. So this is the question. We want to find the general and the particular solution for this question. So what do we do? This is the question. The square y, the x square is equal to 4x plus 3. This is second order of differential equation. So we integrate both sides. And when we integrate, we are going to have the square y, the x square equal to, we integrate this as well, 4x plus 3 with respect to the x. By the time we integrate this, then the first derivative will disappear. We have the y with respect to the x equal to, and when we integrate this, of course, we know it's going to be 4x raised to the power of 2 divided by 2. So 4x squared over 2. And these two will cancel this later. Plus this will be 3x. Then we apply constant term. Because it is second derivative, so this will be first constant we are going to generate. Let's call it C1. So then let's find this. We have the y, the x equal to, this one will be 2x squared, then plus 3x plus c1. Now we have to, let's call this equation 1. We will integrate it again. Let's integrate again. Let's integrate both sides again. We are going to have integral the y equal to integral. So this will be 2x squared plus 3x plus c1 with respect to the x. Then when we integrate the y, this will change to y equal to, if we integrate this to be 2x raised to the power of 3, by the time we add 1 to this, then we divide by the power again, plus this again will give you 3x, we add 1 to this, making 2, divide by the power again, which is 2. Then this is a constant term, just like we integrated this and we said it is 3x. Likewise, this is a constant term like 3. This will be c1x. Then we have another constant term again, which is plus 2. Now, let's substitute the value of this point, this and this. For the first point at 2, 3, and this is our coordinate, which is y, x, and y. So let's substitute. When y is 3, we have 3 equal to 2 over 3 times our x is 2. So we have 2 raised to the power of 3, then plus 2 or 3 over 2x, which is x is 2 raised to the power of 2, then plus c, which is 2, x is 2 c1, then plus c2. Here what will happen, this will be 3 equal to, and this will be 8, and 8 times 2 will give us 16 over 3, then plus this will give you 4, and 4 divided by 2, it will be 2 times this, it will be 6, then this will be plus 2c1 plus c2. We can find this one. Let me multiply everything by 3. If you multiply everything by 3 here, this will be 9 equal to 16 plus this times 3 will give you 18, then plus 3 times this will give you 6 c1, then times this, we are going to have 3c2. And if you cross multiply, if you collect the like term here, we are going to have if this comes here and this comes here, or this plus this rather, or let's take this to this side. When this comes here and we subtract 9 from this 16, so the answer here will be minus it will be minus 7. Then minus 7, when you take minus 7, when this comes here, minus 7 plus minus 18, this will give us a minus 25. Minus 25 equal to 6c1 plus 3c2. Let's call this equation asterisk. So what we are going to do now, we are going to put the second point. So when we put the second point, we find the value again, and if it leads to simultaneous equation, we can easily go there. So let's clean this. So from that place, we are going to have at point 0, 1. So here our x will be 0, our y will be equal to 1. We are using the same equation here. This is the equation we are using. So we are using the same equation. And if you do that, here our y is 1 equal to, I'm substituting to this, this will be 2 over 3 times our x is 0, here 0, then plus 3 over 2 times 0 as well, and this contains x again, so it will be 0 plus 0, then left with c2, and if everything here will be 0, meaning our c2 will be equal to 1. Then we can now substitute this c into this equation asterisk that we have below. So we can now have our 3c2 plus 6c1 equal to minus 25. This is equation asterisk. So our c2 is 1. This will be 3 times 1, then plus 6c1 equal to minus 25. So when we multiply this time this will give you 6. So when this comes here, we are going to have, to give you to the rather, 6c1 equal to minus 25. Then when this comes here, minus, it will be minus 3. And minus 25 minus this, it will be minus 28. Minus 28. Then our c1 will be equal to minus 28 all over what? All over 6. Which is the same thing as minus, what can go? So 3, 2 here, 1. So 2 in this one give you 14 all over. 2 here is 3, 14 over 3. So these values, C1, C2 and C1, we will now take it back to this general solution. Don't forget, this is our general solution. We want to look at the particular solution now. So for the particular solution now, we now have therefore the general solution is 2 over 3 x cubed, then plus 3 over 2 x squared plus c1x plus c2 x c2 rather. So this is our general solution. And our particular solution now, we put the value of c1 and c2. We are going to have 2 over 3 x cubed plus 3 over 2 x squared, then plus, what is our c1? Our c1 is minus 14. So this will be minus 14 over 3x. Then our c2 is 1 plus 1. This is the particular solution. This is our particular solution. I will stop here for today. So in our next class, I will look at the formation of differential equation and the methods of solving differential equations. Help me to like, share to your friends, and put your comments. I'm very grateful. We are not going to stay long in this video. I promise I will upload very soon for this continuation. If you have any problem or you want area you want me to help you with videos as well, I will do that. I remain loyal. Thanks so much.